Thanks, Kevin. Hello, folks. As Kevin said, my name is Eric Simone. I'm the founder and CEO of ClearBlade, an IoT edge and AI software company headquartered in Austin, Texas. Though today I'm presenting from my hotel room here in San Francisco. I'm going to outline what intelligent infrastructure is and how we leverage intelligent assets to increase security and visibility of critical infrastructure across the US and the world. So let's get started. First, let's define critical infrastructure before we define intelligent infrastructure. So critical infrastructure includes the vast networks of highways connecting bridges and tunnels, railways, utilities, and buildings necessary to maintain normalcy in daily life. This is the definition from the US Department of Homeland Security. Transportation, commerce, clean water, and electricity all rely on these systems. At ClearBlade, we have been involved with connecting and securing critical infrastructure across the world, including aviation, bridges, broadband, drinking water, energy, rail, roads, buildings, stormwater, and transit. To modernize this infrastructure is a very complex problem, which involves many different types of technologies and physical assets, and there is a clear and present need to do so today. Why? Well, let's take a look at the current state of America's infrastructure. In 2021, the report card on American infrastructure is a bit concerning. Overall, American infrastructure earned a C- in 2021. Now, that's up from a D earlier. The bottom end of the average, but out of the D range for the first time in 20 years. Yet, when you look at the scores individually, a bleak situation looks bleaker. Transit earned the lone D-, but dams, levees, roads, and stormwater systems all got Ds. There's a water main break every 2 minutes, and an estimated 6 billion gallons of treated water lost each day in the US, enough to fill over 9,000 swimming pools. Growing wear and tear on our nation's roads have left 43% of our public roadways in poor or mediocre condition, a number that has remained stagnant over the past several years. And there are 30,000 miles of inventoried levees across the US, and an additional 10,000 miles of levees whose location and condition are unknown. The reason? Well, most of America's infrastructure was built post-World War II. So much of it is over 50 years old. I listened to a fabulous podcast the other day by the Civil Engineering Podcast, a fabulous resource for information on intelligent infrastructure from a different perspective, a civil engineering perspective. Episode 172 really excited me. It was all about intelligent infrastructure, a new vision for civil engineering professionals. And it features Dr. Luna Liu, a PhD director of the Center for Intelligent Infrastructure at Purdue University. Go Boilers. She talks about the need for intelligent infrastructure and gives some fascinating examples and perspectives on intelligent infrastructure. Specifically, Purdue has developed smart concrete. This smart concrete can communicate with engineers about its strength, weakness, and need for repair, making road repair more efficient and preventing unnecessary shutdowns. This is just one of thousands of fascinating technologies being applied to make intelligent infrastructure. But how do we connect all this, and what exactly is intelligent infrastructure? Let's make a definition here. Intelligent infrastructure adapts to human needs, making it sustainable, durable, adaptive, autonomous, and secure. Adaptive to human needs, so it notifies its users of its condition. It sends recommendations on its usage. It proactively responds to issues like maintenance issues, natural disasters, security concerns. And there are so many definitions of intelligent infrastructure. Most of them really talk about technology like IoT and edge computing and AI. And I really like this definition because it talks about why we're doing any of this. It gets out of the technology into the reasoning, the fact that it adapts to human needs and serves humanity. There are plans upon plans for all of these initiatives, but how do we make it real? This is the tough stuff. How do we make it real? Let's highlight one organization that is dedicated to delivering intelligent infrastructure. The Autonomy Institute. So this is a 501c3 that ClearBlade's proud to be a part of that is accelerating the path to commerce for intelligent and automated systems. It's enabling intelligent and autonomous communities through collaboration. This includes digital infrastructure, autonomy, and AI at the edge. It's a government, industry, academia, and public alliance to create the policies, markets, jobs, and community benefits of autonomy, starting with intelligent and autonomous infrastructure. That is the equivalent of what the Eisenhower interstate highways were back in the 50s. To me, this is the harder part of the equation, right? We're not even talking technology yet. This is pulling together the governments, the financing, the resources to create intelligent infrastructure. It's a Herculean task. I am proud. ClearBlade is a member of this organization to help with these initiatives to build a stronger and more connected U.S. and world, actually. ClearBlade's also a member of another organization, such as the Blue Sky Consortium, who are focused on similar initiatives worldwide. So let's transition from public policy and funding and talk about how do we deliver our progress to date on delivering these sort of intelligent infrastructures. Well, again, more bad news. To make intelligent infrastructure, you need to leverage IoT, right? That's why we're talking at the IoT community about it. You have to connect all of these disparate things and systems. It's a daunting task. To date, custom building these solutions to achieve intelligent infrastructure has failed. It is well documented that at least 74% of IoT projects fail. I think it's actually higher from what we've seen in the field. And why is this? Well, the conventional wisdom has been to custom build these solutions, piecing together various IoT services provided by the cloud vendors. The issues that I see are, look, approach. Most are taking the same flawed approach, building from too low of a level with IoT cloud services. I call this Lego bricks in the cloud. Duration. IoT projects take too long to complete. Expense. Custom building is risky and expensive. Expertise. Most enterprises are focused on different things. They're not software companies. They lack the necessary expertise to deliver these systems. Expectations. A lot of folks go into this with unrealistic expectations on how to connect this all. It's easy to connect one or two things, but when you start connecting hundreds and thousands and millions of things, it gets very, very hard. And last but not least, integration. This is real important. You have to be able to integrate with existing systems that have been around for 20, 30, 40 years or more. And this is a key component of making all this stuff work together. So for the last decade, the majority of IoT initiatives have followed the same flawed playbook. So the conventional wisdom is not wise. We have to change the way we do this. We have to shift the approach from custom building solutions to utilization of flexible, purpose-built software for intelligent infrastructure. So how do we do this? Well, we need digital twin software built on open, flexible, and proven IoT edge and AI technology. Again, I love talking about IoT edge and AI. I love technology, but man, we've got to create an abstraction so business people and operators can use this stuff. What an intelligent infrastructure software must be is consistent, proven and repeatable software. It's got to be fast. You got to be able to deliver results in a few days a week, not just the software being fast, but the actual ROI has to be extremely fast. Flexible, ability to run on any edge or cloud and communicate with any physical device. Open, free flow of data, API, flow the data to where the government wants it, where the enterprise wants it, where everybody wants it, right? The data's got to go all places. Cost effective. It's got to be cost effective at massive scale. It's another issue with this custom build approach. Everything's fine when you're a few thousand devices. You start getting into hundreds of thousands or millions, it gets too expensive. And business focus. It's got to be able to be delivered to business people who don't have a degree in computer science, who don't know how to code, but know everything about their assets and what they want to monitor and provide. So we have to shift the approach from custom building solutions to flexible, purpose-built software to deliver digital twins for intelligent infrastructure. But let's talk about the definition of digital twins for a minute. This definition came out in the early 2000s. What is a digital twin? This is back when BlackBerries were the definition of smartphone. This is back when Matrix Resurrections and Star Wars Episode 2 were in the theaters. We're just starting to do real commerce on the internet, and there's no such thing as software as a service. Back then, a digital twin meant a disconnected copy of data generated by a physical device like a jet engine. So this definition contains some slippery terms like intended or actual real-world physical product. Effectively indistinguishable digital counterpart, and simulation. This keeps the digital twin in the lab or stuck in the computer where theoretical testing can be done. It's valuable, but not groundbreaking anymore. This is not what I think of when I think digital twin in today's world with today's technology. The sad truth is today's digital twins are not connected in real time. To build intelligent infrastructure, we must have connected digital twins, delivering real-time information to operators. And it's all about the operators. The operators manage and run the infrastructure, and we need to put this power into their hands every day. People who know how to use it. So what is needed for today's digital twins is connectivity. So we must update the definition. So an updated definition is a digital twin is a digital model connected to a real-world physical product, system, or process, a physical twin that serves as the digital counterpart for practical purposes, such as integration, monitoring, and maintenance. This is a more modern definition, at least for what we need to do to create intelligent infrastructure. Digital twins needs IoT connectivity. We call these intelligent assets, and we can use intelligent assets to build intelligent infrastructure. Now that we have an updated definition of digital twins, let's talk about software needed to deliver connected digital twins. Intelligent assets. No-code digital twin creation software for operators. Operators create digital twins to monitor and control any physical asset, all without needing a computer science degree to use. Intelligent assets is in use today across multiple industries, including buildings, energy, rail, oil and gas, among others. This software enables field operators to quickly configure and visualize equipment. They can create rules and alerts all with simple forms. No drag and drop, no connecting lines, simple forms. Using the terms they use in their industry. It's configured by industry. Intelligent assets integrates with existing enterprise and AI software, another key component. There's nothing better than giving a data science tagged, normalized data with lots of extra information to turn around and create an AI model. I'll touch more on that a little bit later. This shifts the approach away from custom building solutions to quickly delivering value through flexible, purpose-built software for creating intelligent infrastructure. If you're not aware, and Kevin said it earlier, the IoT community made a major announcement today. Gen AIoT, a new industry solution category that fuses generative AI and AIoT to operationalize industrial and enterprise IoT. It's very exciting. The inaugural members are SAS, ClearBlade, SoftServe, and Intellias, all companies ClearBlade is working with to deliver this exciting new chapter in IoT. Listen, Gen AI is going to revolutionize the way we deliver digital twins and intelligent infrastructure. I was so happy when Kevin contacted me about this because at ClearBlade, we have been incorporating Gen AI into our products for the last several months. And we have already built Gen AI capabilities into our popular intelligent assets product. It's so easy, even a CEO can do it. For example, an operator will be able to enter in a description of the type of assets they want to create and what attributes they want to monitor. I like to demo Zambonis because I'm a big hockey fan. So I typed in, I want to monitor my fleet of 32 Zamboni ice resurfacers. I want to track the location, battery level, oil level, and engine temperature of each Zamboni. And if the oil level is below 50%, I want to receive an email. Instead of having to click through multiple windows to set all these up, these digital twin assets will be automatically created. We will continue to invest in this area, ingesting asset manuals to further enhance the capabilities to actually physically connect to the device, to suggest typical monitoring parameters, to create and suggest rules and alerts, and more. That what we can do with this technology is virtually endless, and I can't believe how quick we've done this over the last few months. And I'm proud to announce that next month we are releasing Gen AI for intelligent assets. So an April release, that's how close we are. We see this as the next big thing in IoT and connected digital twin technology. So now let's get a little bit deeper and look under the hood on how intelligent assets leverages IoT and edge technology to deliver this amazing operator experience. Here's where I get a little bit nerdy, and I can't help myself. The engineer in me loves to do this stuff. All right. So first, we've got all our field assets. So imagine whatever you're trying to connect, whether it's buildings, trains, whether it's pumps, digital cameras, scooters, you name it, any physical asset in the field. And first, we need to connect these by streaming data, raw data into the cloud. So that's the first step. So we're getting Modbus data, we're getting hexadecimal data, CAN bus, all these different protocols, right? But we can then take that and normalize the data structure and deliver it into the Intelligent Assets software product. Intelligent Assets then shares additional asset information back to the cloud, because as the operator enriches this information by adding features, by adding comments, by basically structuring how they're working with those physical assets, we gather more data around the asset itself, how it's being used. This is very, very valuable for feeding into AI systems. Assets are now updated in the field as well. So if we want to push firmware down, we can do this through this mechanism. Next, we can use all of this enriched asset data to create AI models much faster because all of this data is organized. Look, we do a lot of work with SAS Institute, and they are kind of the OG, the original AI folks, dating back to 76, analytics and AI. And that partnership has been fantastic because we can now stream normalized, tagged, structured data into their SAS Viya product, and then they can quickly turn around and create an AI model. This is exactly what we're talking about right here. And we can use other sorts of AI tools. That's really up to the customer, up to the partner on who we're using. All of this enables the operator to perform digital twin orchestration, create rules, alerts, and actions to create workflows around these physical digital twins, and then perform dynamic inferencing, machine learning and AI, like I just mentioned. So this in it alone is powerful, right? This is the device to cloud to intelligent assets. This we do all the time. But now let's put a twist on this. How do we leverage edge computing in this picture? So when we add an edge, it further enhances our operations. Maybe we've got, say, more high-end equipment that we want to attach an edge to. An edge is like a Linux gateway in this context, running processing locally. So what we can do is stream that raw data now locally to that edge device. Normalize that data at the edge instead of the cloud, reducing transmission, reducing data, reducing cost, right? And actually increasing resiliency and security, because we're keeping all that data local now and not streaming it into the cloud. ClearBlade Edge and IoT Enterprise automatically synchronize the edge. So all that syncing is done automatically. So you've got the data that you want up in the cloud. You don't need to stream all the data, and those are all settings that can be made to say, hey, look, I want to save a copy of this in the cloud, or I don't really need this data. I just want the metadata and so forth. But you can keep all that syncing. It's automatic. Next, you can update the assets locally from the edge, right? So this adds tons of capability here. And then this is the holy grail. I've been saying this for a while now. The killer app for edge is AI. Having those AI models running at the edge allows you to do dynamic inferencing much faster. You can use all the data as opposed to just portions of the data. There are many situations where you're out in remote locations where you don't have the connectivity that you need. Or you may have like a very expensive and slow satellite feed, and you can't stream terabytes of data effectively over that satellite, at least not cost effectively and even fast enough. But when you can move a model out of the cloud to the edge, that's extremely powerful. And we're doing this in a number of places, oil and gas, we're doing it in water. It's fascinating what that opens up. And this is the new movement. You're hearing a lot about it now. We've been talking about edge for a long time here at ClearBlade, over a decade, and we've had this AI capability for a while now. We're so happy that we're starting to see it really blossom. All right, and then last but not least, I talked about this earlier, integrations, right? Whether you're cloud only or cloud plus edge, you have to have the power to flow this data into any system that you have. A lot of enterprise asset management systems like IBM Maximo, ServiceNow, ServiceMax, Oracle, a lot of AI tools. Obviously, I mentioned SaaS, but we can stream into any AI tool. This is one of the real powerful things is you could take AI models that have been built 20, 30 years ago in whatever language and tool and export them in a common format that's supported by lots of big vendors called ONNX. This is the format that ClearBlade has built into our runtime. So a really powerful picture of pulling together edge, cloud, AI, and wrapping it with intelligent assets and delivering it to operators. You delivering it to business people so I can manipulate my digital twins. I can connect to my physical assets. I can stream the data that I need. And I can do this simply with cloud parts initially, and then start to add edge computing. So it's harnessing all the power of these different technical features, but surfacing it in a way that abstracts all of that complexity. This is how you achieve intelligent infrastructure at scale with software like this, because we cannot continue to custom build one-off to reach these visions that we all have. All right, now let's take a step back and highlight a few real-world examples across a few industries. Intelligent buildings. So we are working with a global company of over 200 campuses around the world. And the majority of the buildings in this company had disparate monitoring systems, disparate hardware, unique data protocols, basic reporting and data visualization tools. Given its global presence, the building operations team spent a great deal of time consolidating building energy consumption reports and understanding the operational effectiveness of on-site hardware and equipment. With management focused on near and long-term sustainability goals, the company recognized that a change needed to be made. This company was able to deploy intelligent assets to connect up several hundred campuses across the world in a matter of a few weeks to monitor things like energy usage, water consumption, lighting, etc. Any physical thing in or even around the building that they wanted to monitor. We're doing this with other companies with fleets, and they're using fleets of vehicles and they're monitoring building energy. It's fascinating because you have the flexibility to do this because there's no boundary here. This is not software that's built just for buildings. This is not software that's just built for trains or cars or water. It's software that's built for any physical asset. So all the raw data that they were capturing is now organized, tagged, visualized, and flowing into their databases and AI tools, allowing them to innovate and come up with new solutions for their own infrastructure. And the building operators have the visibility and control they were looking for. All right, now let's move from intelligent buildings to intelligent water. So completely different use case. This company supplies clean water solutions to the Napa Valley, Sonoma, and Russian River areas of California for wine production and for remote locations that do not have access to clean drinking water. They needed a solution to remotely monitor and control their water purification equipment and processes running at various locations to better serve their customers. This company was able to deploy intelligent assets, connect dozens of locations across the area to monitor their equipment, to capture data for state reporting requirements, and to better service their customers by proactively addressing problems before they cause issues. They now have visibility and control to remotely monitor their processes, resulting in happier customers, reduced expenses due to reduced trips to remote locations, and better compliance reporting. Okay, one more. Let's move from intelligent water to intelligent energy. So this one we're doing in concert with SAS. So they've got a solar farm on their campus. And the problem was monitoring the solar farm and addressing the faults in the system is highly critical. It provides energy to one of the campus buildings, 43%, and back to the power grid, 57%. The solar panels and related hardware, such as the tracking motors, cables, et cetera, are prone to failure due to exposure to harsh weather conditions and environmental factors. The previous approach was reactive and planned maintenance strategies. They used them to manage and keep the solar farm working at peak capacity. This strategy resulted in unnecessary downtime and non-essential spending. Parts and equipment were replaced prematurely, and broken parts were causing costly outages. So the desired approach and the solution was a corporate social responsibility commitment to reduce the environmental footprint. Same Same reason for the building company, right? We want to reduce our energy usage. And they really wanted to understand the true operational capacity to make predictions about the power generation based on the meteorological conditions. So they wanted to do advanced AI around this. Obviously, that's what SAS does. So they were able to deploy intelligent assets and rapidly ingest machine data and information coming from inverters, panels, and combiner boxes. Additionally, data from weather patterns were merged to allow for a high-level overview of the productivity of the farm. AI models were directly integrated in real time to inference generation production. Aberration in the predictions from actuals were mapped to common types of mechanical failures and maintenance cycles. These mappings were turned into actionable events and alarms. So the results from this, the photovoltaic solar arrays generate 3.6 million kilowatt hours of clean renewable energy each year for its campus buildings. And the teams are now able to prioritize maintenance recommendations based on potential disruption impact to operators, as well as the ability to make real-time insights into system health as it changes over time. That's a fascinating example and really shows what you can do with the power of connected assets, intelligent infrastructure, and AI. This is how we're going to solve this going forward. So in conclusion, delivering intelligent infrastructure takes flexible, proven software that non-technical, non-computer scientists can use. This is accomplished by abstracting the complexities of IoT, edge, and AI. So ClearBlade provides these things. I won't go into this in detail, but really you're seeing intelligent assets encapsulate all this and deliver it to the end user in a very effective and very quick way. All right, with that, I think we got about 4 minutes or so for any Q&A. I'll pause here, Kevin.